Welcome to the first lesson in Session 2 on the properties of logarithms. We use the properties of logarithms to expand and condense expressions that contain logarithms. This often puts us in a position to help us evaluate a logarithmic expression or possibly solve our logarithmic equations. There are three properties of logarithms. The first is called the product property. The product property reads log base a of m times n is equal to log base a of m plus log base a of n. So we can take a product. If we're taking the log of a product, we can separate that log into two separate logs, connecting them with a plus sign. So log of base a of m times n is equal to log base a of m plus log base a of n. Notice the base has to be the same. So in this case, we have log base 2 of 4 times 8. We can separate that as log base 2 of 4 plus log base 2 of 8. Next, we have the quotient property of logarithms. And it's similar, except it uses division and subtraction as opposed to multiplication and addition. So the quotient property reads log base a of m over n is equal to log base a of n minus log base a of n. In an example of the quotient property, if we have log base 5 of x over 5, that's equal to log base 5 of x minus log base 5 of 5. Notice that the second expression can be simplified. Log base 5 of 5 is equal to 1, so I can evaluate that expression and express it as log base 5 of x minus 1. The third property is called the power property. The power property is much different. It's log base a of m to the n power is equal to n times log base a of m. So what the power property does is it allows us to take an exponent that's inside the log and pull it out to the front and treat it as a multiplier of the log. So an example of the power property, log base 3 of 9 to the 4th is equal, we take that 4th power of 9 to the 4th, pull it out in front, and that becomes 4 times log base 3 of 9. Notice that the logarithmic expression can be simplified. So log base 3 of 9 is equal to 2. So that's 4 times 2, which is equal to 8. In the next set of examples, we're going to expand and condense logarithms. For the next few, we're going to expand. So in the first one, we have log of xy over z. So in the numerator there, we have x times y, so we have the power of the product property, and since it's dividing by z, we have the quotient property. So we'll separate the numerator through addition and the denominator through subtraction, which gives us log of x plus log of y minus log of z. In the next example, we have log of 6 times x to the third times y. So it's a couple of product properties that we need to employ. So that gives us log of 6 plus log of x to the third plus log of y. Notice that middle term has an x to the third. So we'll pull the power property out in front, which gives us log of 6 plus 3 log x plus log of y. Lastly, we have the log base 3 of 2x to the second. A few ways to go about this. The first thing we're going to do is evaluate 2x being raised to the second power, which gives us log base 3 of 4x squared. So now we have the product property as well as the power property. So we use the product property to separate the 4 and the x squared, log base 3 of 4 plus log base 3 of x to the second. And then we use the power property to pull that 2 out in front of the log base 3 of x squared. So our expanded form is log base 3 of 4 plus 2 times log base 3 of x. See, in this next set of examples, we're going to condense each logarithm. So we have log base 5 of 4 plus log base 5 of 3. So notice that the bases are the same, and since they're being added, that's an example of the product property. So we can condense that log and multiply those two numbers, giving us log base 5 of 12. In the next example, we have log base 2 of 4 minus log base 2 of 2 plus log base 2 of 8. So we have the quotient property followed by the product property. And that's going to allow us to express this as log base 2 of 16. Now we can further simplify that. Since 16 can be expressed as a base of 2, log base 2 of 16 is actually equal to 4. Next, we have 2 log of x minus 3 log of y. So we'll first start with the power property. Since each of the logs is being multiplied by a coefficient, we bring that into the log and treat it as an exponent. Log of x squared minus log of y to the third. And now we use the quotient property, we get log of x squared over y to the third. Here in our last slide, we're going to use the properties of logarithms to evaluate without the use of a calculator. So in our first example, we have log base 2 of 4 minus log base 2 of 16. So we're going to use the quotient property here to start simplifying, and that gives us log base 2 of 1/4. And now to evaluate it, we're going to rewrite this as an exponent, which is going to be 2 to the x equals 1/4. Now 1/4 can be expressed as a base 2 as 2 to the negative 2 power, so in this case x is going to be equal to negative 2. Next we have 2 log base 3 of 3 minus log base 3 of 3. So we'd start by reintroducing the coefficient into the logarithm, log base 3 of 9 minus log base 3 of 3, which simplifies to log base 3 of 3. Which should, log base 3 of 3, if you convert that to exponents, that's 3 to the x is equal to 3, so we get a value of 1. In our last couple of examples, we're going to be given specific values of certain logs. So we know that the value of the log of 4 is about 0.602, the value of the log of 5 is about 0.699, and the value of the log of 6 is about 0.778. So we're going to use the properties of logarithms to evaluate each expression. We've got to do so without using a calculator. So we want to try to find values of 4, 5, and 6 within these logs. So in the first example, we have the log of 24. And we need to find 4, 5, or 6. Since we're dealing with 24 in this first example, I know that the 6 times 4 is equal to 24. So I'm going to use that to my advantage. And I'm going to use the product property to separate that log into the log of 6 plus log of 4. We use those 6 and the 4 because we have values of the log of 6 and the log of 4. So I'm going to substitute those values into that expression now. We know that the log of 6 is equal to about 0.602 and the log of 4 is equal to about 0.778. So we can add those two values and we get 1.38. So we know the log of 24 is equal to about 1.38. The last example, we have the log of 125. Since we know that the log of 5 is equal to 0.699 and 125 can be expressed using a base 5, I rewrite log of 125 as a log of 5 to the third. The power property allows me to peel that 3 off and place it out in front, express it as a coefficient. Now I have 3 times the log of 5. And I know the value of the log of 5 to be about 0.699, so I can now substitute that in for the log of 5, which gives me 3 times 0.699, which evaluates to 2.097. So the log of 125 is equal to about 2.097. So that wraps up this lesson. Good luck on your quiz, and please email us if you have any questions.